Hello, 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 hello. I welcome you again to Simplified RSA. We are the guys who makes it looks easy. I'm Mr. Maimane. And then today we are looking at another question, which is a question that is on paper one of mathematics for grade 12 students. And the question that we have is question 10. And the question reads, EHGF is a rectangle whereby HE is produced x squared centimeters to n, and EH produced x squared centimeters to p. And we are given that NF produced intersects PG produced at M to form an isosceles triangle, which is MNP, with NM being equals to MP. And we are also given that D lies on NP where MD is perpendicular to NP. And then the size of NP is equals to 4 centimeters and the size of MD is equals to 3 centimeters. And then for the questions, we are required to, for 10.1, we are required to show that the area of EFGH is given by AX. A of x is equals to 6x squared minus 3x to the exponent 4. And 2.2, we have to calculate the maximum area of triangle EFGH. Now, interesting question, because the whole concept here is to know that in order to calculate an area of a rectangle or to show the expression of an area of a rectangle, you must know that you have to calculate the length. You have to multiply the length of the rectangle with the width of the rectangle, also known as length times breadth. But before we go further, let's analyze the situation that we have. So now, looking at the given triangle and the given rectangle inside the triangle, we need to find the length of the triangle. By the length of the triangle, I mean EF, which is given as B. This one here, EF. We need to find the value of B in terms of X for us to can determine what we are required to. And to do that, look at this. Somehow we can tell that triangle NEF is very much similar to triangle NDM. These two triangles are similar. And what makes the two triangles similar is because angle N is common between the two triangles. This angle here, N, is common between the two triangles. And we can see also that if angle MDN, this angle here is 90 degrees because it's perpendicular to, because MD is perpendicular to NP, somehow also this angle FEN is also 90 degrees there. So meaning if the two angles are equal, clearly by definition, the third angle will also be equals. The third angle will also be equal, meaning this angle here, angle NMD is equals to angle NFE, this angle here. So now, by definition, triangle NEF is very much similar to triangle NDM. And because of that, we can use our application of similarities to can calculate or rather to get the expression of B in this case. Then I will say NE over FE. NE over FE is equals to ND over MD, as you can see there, because the two triangles are similar. In similarities, we do apply it like this. I know the size of NE is x squared. I know the size of ND is going to be 2 centimeters because NP is 4 centimeters. And I can see that this side is equals to this side. So ND is equals to DP. And because of that, if the whole full NP is 4 centimeters, I can tell that ND is 2 centimeters, NDP is 2 centimeters. Let's apply it. So let's go. Like I say, NE over FE is equals to ND over MD because the two triangles are similar. And NE is given to be x squared all over FE. I can tell that FE is 2. No. FE is given by B from the image there. This is equals to ND is the one that is 2 rather, all over MD. MD is 3 centimeters as given. And then from here, I can express B. If I cross multiply here, I will have that 2B is equals to 3x squared. And to get B, I will divide by 2 both sides. This cancels that. Therefore, B is equals to 3x squared over 2. That would be the B that I have. Now, let's get EH for the width. For EH, I can tell that NP is given. NP is composed of NE plus EH plus HP, as I can see there. NP, I know NP is 4 centimeters. It's equals to NE, I know it's x squared plus EH plus x squared for HP. Now I can express EH as EH is gonna be 4 minus x squared plus x squared is gonna be 2x squared, like that. And then I can now attempt to get my area. So now for the area of EFGH, I can tell that it's gonna be FE multiplied by EH. And in this case, I know that FE is B times EH, which is 4 minus 2x squared, like that. But I know B is the same as 3x squared over 2. So here, I'm going to remove this and write it as 3x squared over 2. Therefore, here I can FOIL this by multiplying this one here and multiplying this one there to show that the expression is going to be the same now. Therefore, this is going to be 3x squared over 2 times 4. As you can see, this is going to be, let me just put it as 12x squared over 2 minus this times that is going to be minus 6x squared over 2. And they are both divided by 2. And then this is going to be equals to 12 divided by 2 is going to be 6x squared minus 6 divided by 2 is going to be 3. Oh, no. If I multiply this by that, there it's going to be 6x to the exponent 4 rather. I don't know why did I put it as squared. So we're going to have this situation here, which makes 6 divided by 2 is going to be minus 3x to the exponent 4, which indeed shows that the expression of AX is indeed 6x squared minus 3x to the exponent 4, which is what we were required to show. So there we go. We have it. But the key word was just to know that for area, it's length times the breadth. Now, 10.2 is very much interesting. I have to calculate the maximum area for the rectangle EFGH, of which at this point I already have the expression for that rectangle. Let me tell you something. Whenever you hear the word maximum and you have to determine the maximum area of something, not just in this situation, you must know that you have to differentiate, solve for x, and then take the maximum value, and then you substitute it to the original given expression, just like when we are getting a turning point for a quadratic function, something like that, similar there. So now, this is how we're going to go. We already know that the expression of A of that area is A of x is equals to 6x squared minus 3x to the exponent 4, right? And then I will differentiate this and equate it to 0. So I will have A prime x is equals to, if I differentiate this, it's going to be 12x, because it's 6 times 2 and then 2 minus 1. Therefore, for this one, it's going to be minus 12x to the exponent 3, because it's 4 times 3 as well as 4 minus 1, the exponents. And then we get this expression here. Therefore, 12x minus 12x cubed is equals to 0. And then I will solve for x here. Just to put this properly, I can write it like this, such that I wanna have my first factor as a positive. So I will have, if I multiply by negative throughout, I will have 12x to the exponent 3 minus 12x is equals to 0. Here I have a common factor of 12. If I take out, it's 12x actually. If I take out the common factor of 12x, I'm left with x squared minus 1 is equals to 0. And I can factorize this one further, such that I will have x squared, 12x squared is x minus 1, and x plus 1, because I have the difference of 2 squares there, such that the value of x for this one would be x is equals to 0, or for this one, x is equals to 1, and then for this one, I have, or x is equals to minus 1. But I want the maximum value for x. So for the maximum value, I'll take the maximum value I here, because 0, an area cannot be 0, obviously. But then between this and this one is the minimum, this one is the maximum. So I will take this one. So I will then go and say A to the x is equals to 6x squared minus 3x to the exponent 4. Therefore, what would be A of 1? A of 1 would be 1 squared minus 3. I put the 1 there to the exponent 4. If I simplify this, I will have 1 squared is just going to be 1. So I will have 6 minus 1 to the exponent 4 is also going to be 1. So it's going to be 6 minus 3, which makes the maximum area to be 3. That's what you get. So the maximum area that was required, the maximum area for rectangle EFG is 3. Thank you for your time. Thank you for watching. Don't forget to subscribe to our YouTube channel and do follow us in all our social media platforms. And at this point, feel free to contact us whenever you want to inquire about our private lessons on mathematics and physics. You can send us a WhatsApp or an email from any of the contacts here. At the end of the day, we are here for you. Please do subscribe to make sure you catch up in all the videos that we upload based on academic content for mathematics and physics. I'm Mr. Maimane. This is Simplified RSA, and we are the guys who makes it looks easy. Thank you.